So, understanding how vehicles behave during atmospheric reentry will help give future spacecraft developers some unique information that can enhance their design efficiencies and safety. One experiment that has had 3 successful flights to gather this never-before collected information. Why don't we join Lori Meggs now out at the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, to learn more about the Reentry Breakup Recorder. Lori?
It's a wild ride for the Reentry Breakup Recorder, but an important one. It tests a system that rides a space vehicle, then records data as it re-enters the atmosphere and breaks up, and then it returns that data for analysis. We spoke with Andrew Feistel from the Aerospace Corporation to find out more about this first-of-its-kind test.
We care about attaining reentry breakup data because there have been observational campaigns in the past that are watching reentries from cameras, kind of high-level things we could pull from that data, but there's a real lack of real precise, detailed, real-time data that comes from the reentering vehicle during that reentry time frame. That data is the data that Reber is recording and transmitting back to us.
How is it transmitted back to you if this is breaking up?
It is essentially a phone with a heat shield. It transmits via the Iridium satellite phone system, and it does this all while still falling to the ground. There's only a few minutes we have of data communication time, but we get all of the data that we need that is essential about that initial reentry breakup process, and it comes to us on a website.
How many times have you flown this reentry recorder?
There have been 4 flights, all courtesy of ISS resupply craft. 3 of the 4 flights were successful. The one that was not successful, we just don't know why, never made the phone call. But the 3 that were successful gave data such as temperature, pressures, rotation rates, accelerations about the host vehicle that are helping us better define the survivability of future reentering space vehicles.
So that is the goal, to find out how to
better our current models that are predicting survivability of space vehicles, re-entering space vehicles.
What are you learning from the data?
Well, one of the main things we're learning from the data is kind of these high-level altitude regions of which significant events are happening, and we're seeing, at least with these 3 ISS resupply craft that have returned data, the major significant breakup events tend to be happening about 74 to 70 kilometers. I call that out specifically because there's a historical 78 kilometers that is used somewhat as an input to a lot of current modeling simulations, and the specific altitude that the breakup event occurs has a huge impact on the footprint, the debris field, when it goes down all the way to the ground. Kind of like a shotgun, the closer or further away from you, the faster it will disperse.
The first data ever recorded during the breakup reentry occurred on JAXA's HTV-2 vehicle after it departed the station. Now, the data returned by Reber has helped calibrate reentry breakup and reentry hazard prediction models worldwide, and there are 2 more tests planned for this in 2015.